Hello friends, welcome again to the tetrahedron chemistry classes. So guys, in today's class I am going to discuss the solved problems of S block elements. As you know, I have already discussed the chemistry of the S block elements completely. First I took alkali metals and then I took alkaline earth metals. Okay, so I have covered the things about S block elements in pretty much detail. Now I am going to discuss the 100 solved problems of S block elements, which would be roughly 80% different from the problems which I have already discussed in my lectures. Okay, and these problems are very important for any students, be it BSc student, or you are doing your BTech first year, or you are JEE aspirants, or you are going for CSIR, NET, GATE, whatever the exam is there, right? These 100 problems are going to be very important for all of you. Okay, and you know, it is not possible to solve 100 problems in one particular lecture, so I'll make a series of these lectures. In the first lecture of this series, I'm going to discuss only 21 problems, right? And these 21 problems also take somewhere around 40 to 50 minutes to complete, right, to explain the problems thoroughly. Okay, so without wasting too much of the time, let's start what actually the problem says. Okay, so my first problem, as you can see guys here, what it says: calcium cyanamide reacts with the steam to form the ammonia, and you have been given four options, and out of these four options you have to correct the first one. So for this, if you have studied the S block elements completely, then this problem is very easy for you. However, it's a theoretical kind of the problem, right? If you have learned the formula of the calcium cyanamide, and you have learned the reaction, only then you will be able to solve this kind of the question. There is no concept involved in it, but you have to memorize these things. So okay, so this is your calcium cyanamide, CaCN2. Okay, and it is reacting with the steam, that means water. Okay, and you see, I'm writing G here. G stands for the gas. Okay, so what products you will get here? So I'm not having space, that's why I'm drawing the arrow in this manner actually, right? So you can write properly. Okay, and when this will react, of course the one of the product is given already in the reaction, which is the ammonia, and the second product which this will form is the calcium carbonate, CaCO3, right? So this CaCO3 is the answer. So you can mark as option D as the correct option. Now moving to the next problem, that is the problem number 2. Lithium has much higher ionization energy than the cesium, right? It's quite obvious. Lithium is the first member of the series, and due to the anomalous behavior, because it is having the two smaller size and very high charge concentrated on that smaller area, or smaller volume rather. Okay, so it is having the very high ionization potential. This I have explained in my lecture also. But in aqueous solution, that means if you dissolve this lithium in the aqueous solution, it will form the Li positive ion. Lithium is more powerful reducing agent. Of course, this is more powerful reducing agent, because in that case the hydration energy of the lithium is quite high. You should remember this particular point. It is very important. There is nothing serious about this question. If you have followed my lecture, then it would be very easy to mark this option C as the correct option, right? So you know, this lithium is quite smaller in size. Okay, when it is very smaller in size, so that means it can attract the negative dipole of the water. So if you are having this water here in the aqueous solution, of course you will have this one. So this lithium ion easily gets hydrated, right? And when it's easily gets hydrated, its hydration energy is quite high. Hydration energy is high, and you know, the reason of the high hydration energy means that the lithium has the high affinity for the water. Okay, that's why the hydration energy is very high. And since you know, when you are dissolving lithium in the water, it is producing Li positive ion, and you know, this is actually shows the reducing natures. That means, what is the modern definition of the reduction? Decrease in the oxidation number. Modern definition is what? Decrease in the oxidation number. And how we can decrease the oxidation number? Only by supplying the electron. And this lithium actually, when dissolved in the water, it readily forms the Li positive. In that manner you can write, say, if you are having the lithium, you have dissolved in the water, so it will readily lose electron, okay, and this will form Li positive ion, which easily gets hydrated with the water, okay, and this electron actually is used to reduce the certain species. That's why it behaves as the strong reducing agent is the aqueous solution, okay. However, the first option, you can see the outermost shell of the electron is easily lost by the lithium. No, it is not possible, because question itself says the high ionization potential is very high. So this option cannot be the correct option, right? So you can straightforward mark this as the wrong one. Similarly, if you go for the this B, the outermost electron is more easily lost by the cesium. Of course, ionization potential of the cesium is very low, so its electron would be very easily lost. But the question is about lithium, but not about the cesium. Okay, so you can easily discard this option also, right? And similarly, if you go for the last option, my last option is what? The hydration energy of cesium positive is very high, and you know, in the periodic variation, when you move down the group, hydration energy decreases. So cesium positive ion cannot have the high hydration energy. So you can also mark this F4 as the wrong option. So only correct answer is the option number C. Now moving to the next problem, what it says: amongst the following hydroxides, the one which has the lowest value of the Kp at ordinary temperature is, you have been given 4 options, but I have to correct something in this question, and the correction is, this is not Kp guys, this is Ksp, solubility product value. This is solubility product value. So how we can actually solve this particular problem? So first of all, you should know the behavior of the alkali metal hydroxides, and you know the solubility of these hydroxides, alkali metal hydroxides. When you move down the group, actually solubility increases. Solubility increases. This I have explained in my lecture also. It simply means, when you are having, say, these species, first you will have your beryllium hydroxide, okay, and after beryllium you will have your magnesium hydroxide. After magnesium hydroxide, you are having your calcium hydroxide, and after calcium hydroxide you are having your strontium hydroxide, but it is not given in the question. Then you can straightforward write your barium hydroxide, okay. So this is the scenario actually, and you know, this is the least soluble. This beryllium hydroxide is least soluble, and in the question itself you can see here, your solution is C, among the following hydroxide, the one which has the lowest value of the Ksp at the ordinary temperature, right? So in that case, you see when actually the precipitation would occur, okay. You know, this Ksp, this solubility product is directly related to the what? Solubility. When solubility is low, then definitely Ksp is also low. And you should remember, when we move down the group, solubility increases. When solubility increases, solubility product also increases. Since this is least soluble, so it will have the lowest value of the this beryllium hydroxide would have the lowest value of your solubility product. So in that case, you can simply mark your option D, I think. Yes, option D is the correct option. So this is your correct answer, right? Now moving to the next problem, what it says: electric cookers have a coating that protects them against fire. The coating is made up of, see this guys, this problem is rather simple problem. It's a theoretical problem. So if I write solution here, you know, if you are having your magnesium hydroxide, so the magnesium hydroxide is used in the furnace, right? Linings in the furnaces actually done by this magnesium oxide. Why? Because it is having very high melting point. Very high melting point. When the melting point is very high, it does not catch fire. It does not catch fire. So magnesium hydroxide in the magnesium oxide in that case is the correct answer. Okay, now moving to the next problem. Okay, your next problem, guys, you can see here: microcosmic salt, when heated strongly, a transparent bead is formed which is used in the identification of zinc oxide, aluminum oxide, iron oxide, or the silica. So again, guys, this is the theoretical kind of the problem. And first of all, you should know what is microcosmic salt and how it decomposes. It is very important. So reaction is like that only. This is your Na, NH4 whole twice, HPO4, right? Ammonium, sodium, hydrogen, phosphate. This is your microcosmic salt. I can write. And when you heat this microcosmic salt, it produces sodium metaphosphate, NaPO3, and it is basically analogous to sodium hexametaphosphate. So NS, okay, sodium hexametaphosphate or sodium metaphosphate, okay, and then it releases ammonia, NH3, and then steam. Basically, this hexametaphosphate is a transparent bead. And various kinds of the analysis can be done by this bead, but in that case, because it is a theoretical answer, there is no logic involved in it. So I am telling you the correct answer is the option D. It is used in the actually as silica. So what is the reason actually? Your sodium hexametaphosphate is basically a dispersion agent, okay, and when it is mixed into the soil, then it will actually prevent the clay plate test from sticking to each other in the sedimentation process basically, okay, and this is required in the hydrometer analysis of the soil to determine the silt and the clay fraction present in the soil. So silt, you know, this is what silica. So silica is the actually your correct answer in that case. Option number D you can mark as the correct option. Now moving to the next problem, the problem number 6. The products of the electrolysis of the NaCl salt solution are. So this is rather very simple problem, and because I have written this problem here, so I am solving it. Otherwise there is no need to solve this kind of easy here. Say your sodium chloride you are having, and you are doing your electrolysis, it will produce the Na positive and your Cl negative, right? And then you know when you are doing the electrolysis, you will have the anode and the cathode in that same. So first of all, I am writing the reaction at the anode. So reaction which will happen at the anode. You know the anode is positively charged, it will attract the negatively charged ion. And negatively charged ion in that case is what, guys? It is your Cl negative, right? And this Cl negative when loses electron, so it will give you the Cl2. If you want to balance this reaction, you will take 2 of this and you will take 2 of this, right? So at the anode you are having the chlorine, okay. So check in which options your chlorines are given. In the first option chlorine is given, this could be the answer. In the second option this chlorine is not given here, so you can quickly strike out the option B, right? This cannot be correct answer. However, this C is having chlorine, your D is also having chlorine along with the A. So out of these three, A, C, D, anyone could be correct, and we can check what's actually happens next. So I am writing here reaction at cathode. Reaction at cathode. You know cathode is negatively charged. It will always attract the positively charged ions, and you know your positively charged ion is what? Sodium ion, okay. And this sodium ion, if you take 2 of this, right, and it will consume 2 electrons, it will give you the 2 of sodium, okay. This is how you can write this thing. And you know you have also taken water. So this water easily undergoes the electrolysis, and hydrogen gets removed from here along with the 2 OH negative, right? And what can happen of the sodium which are formed above, they can take 2 of OH negative to produce 2 of NaOH. So you are having your, say, if I write here, first product is this, my second product is this, and my third product is this, and fourth is this. Not actually, you can discard this second one because it is combining. So you are having hydrogen, and you are having your NaOH, and you are having the chlorine. Okay, and if you check the option, NaOH is given here, chlorine is here, oxygen is given, so this cannot be correct answer. And similarly, in the first option also, it cannot be correct because in that case hydrogen is not involved. So option C is looking correct in that case. Okay, this is how you can solve the problem. Now I need some of the space, so I am removing this thing, and what you can do, you can take the snapshot of this. Okay, so what is my next problem? The problem number 7. The principal products obtained on heating the iodine with concentrated caustic soda solution. Okay, you know concentrated caustic soda solution is the NaOH solution. So this is quite straightforward and easy problem, and you must have studied this in your class 11th, I think. Okay, so I am writing the reaction here. You are having the caustic solution, which is NaOH, and you are reacting with this iodine. Okay, and the obvious product would be your sodium iodate, NaIO3, along with the sodium iodide. Okay, so let's check the option. Option number B is looking correct, so you can mark this option B as the correct answer. Now moving to the next problem. The chloride that can be extracted with ether is NaCl, LiCl, BaCl2 and CaCl2. Now again, this is the simple problem, but some concept is involved here. Okay, so you have to look for the details also. Say if I write here my lithium chloride, right? After my lithium chloride, I am having my sodium chloride, and after here your calcium chloride and your barium chloride is given here, right? Okay, and you know, out of these two, this lithium chloride is covalent in nature because ionization potential is very high for this lithium ion, so it easily forms the covalent compound. So it is having the more covalent character when compared to the sodium chloride. Okay, and out of these two, you know, these two are see, first member, if you go for the second one, right, second series, so your beryllium chloride comes first, followed by your magnesium chloride, then your calcium chloride. So it is obviously ionic in nature. Barium chloride is actually covalent, but it is not given in the question. But calcium chloride is ionic when compared to the lithium chloride. So among these four salts which are given in the options, your lithium chloride is the most covalent in nature, and you know, you are extracting it with the ether. Ether, you know, it is, if I take the dimethyl ether for example, right, or diethyl ether, so it is the organic compound. Organic compound is covalent in nature, and you know the concept of the solubility, like dissolve like. That means covalent compound will dissolve in the covalent solvent. Okay, or you can say the non-polar solvent. So lithium is more readily soluble in the ether, so that's why lithium chloride can be extracted very easily with the help of the ether, while other being your ionic compound, they cannot be extracted with the ether. So what you can do, you can mark your lithium chloride as the correct answer. Okay, now moving to the next problem. Okay, my next problem is, which of the following hydride is most stable? So you have been given your cesium hydride, sodium hydride, potassium hydride and lithium hydride. So if I can write their order, so lithium hydride would come first, followed by your sodium hydride, and after sodium hydride you will have your potassium hydride, and then you are having the cesium hydride. Okay, and you know, if you see this one, Li positive, smallest in size. Similarly, your hydride is also small. That means what can happen? It's this polarizing power of this is very high, and it can easily polarize this H negative ion. So basically, their size are compatible. So when their size are compatible, so small cation would easily accommodate the small anion. So it will result of stable compound. So according to me, the correct answer is the option D. While if you think about your sodium hydride is bigger in size, right? And there is no compatibility of the sodium ion with the small hydride ion. So this cannot be stable actually. Okay, and you know the stability degree for hydride, stability decreases down the group. I have discussed the reason also there. Why? See, when the small ions actually combines to form a particular kind of the compound, lattice energy would be very high. So basically, this lithium hydride would have the very highest lattice energy compared to the other hydrides. That's why this lithium hydride is the correct answer. Now moving to the next problem, what it says, sulfates of which of the following does not form alum. So this I have already told you in my lectures also. So if I take the example of the any alum, right, say potash alum, K2SO4, Al2SO4 and dot 24 water of crystallization. If I take like that, okay, you know this aluminium is bigger in size, potassium is also comparatively very bigger in size, so it can this potassium actually can stabilize the bigger aluminium ion. That's why it can form the your alum. But again, the anomalous behavior of lithium does not allow lithium to form the alum. You know, your Li positive ion, it is very small in size, and it is so small that it cannot form a stable lattice required for the formation of the alum. Okay, so this D is the correct answer in that case. Okay, this I have explained in my lecture also. Now moving to the next problem. K2CS3 can be called potassium. You have been given sulfocyanide, thiocarbide, thiocarbonate, thiocyanate. Okay, this is simple problem. You might have studied in class 11. You know, this is your K2CO3, which is your potassium carbonate. So what I can do, I can, you know, oxygen is the first member and then your sulfur. Okay, if I substitute oxygen with sulfur, so what I'll get? K2CS3. And you know, when we introduce sulfur somewhere, the name for the sulfur is the thio, right? And carbon is already there. So basically it is potassium thiocarbonate. This compound is potassium thiocarbonate. Option C is looking the correct answer. Okay. Now moving to the next problem, what it says. The setting of the plaster of Paris takes place with the loss of the carbon dioxide A, hydrolysis B, hydration C, and dehydration D. So this is again a very simple problem. If you have studied your cement chemistry in your class 12, then you know the setting of the cement actually requires the setting of the cements occurs through the formation of the gypsum, and the formation of the gypsum takes place by the process of the hydration. So in that case also your correct answer should be your hydration. That is option C should be correct one. But let us check how we can solve the problem. Say you are having your CaSO4 dot half H2O, right? Hemihydrate, calcium sulfate, hemihydrate. Okay, and this calcium sulfate hemihydrate is what? This is POP, plaster of Paris. This is plaster of Paris, and when it combines with the water, say H2O, it forms the gypsum. Gypsum is what? CaSO4 dot 2H2O. This is gypsum. I can write gypsum here. This is actually the process of the setting of the cement. And if you want to write 2 here, H2O, so here you have to balance this. You can write 3/2. Okay, that's how you can balance the reaction. It's quite obvious. You see, you are having the half of this and 3/2 of this, basically H2O, right? And you know this could be your 4/2 of H2O. It simply means 2 of H2O, which I have written here. So basically it is the process of the hydration which is taking place. So option C is the correct answer. Now moving to the next problem. My next problem is problem number 13. Alkali metals in the liquid ammonia are blue in the color because, see, this problem I have explained in my lecture in the pretty much detail, but again I am going to explain this problem. Basically it is the formation of the ammoniated electron which gives the blue color to the alkali solution. Okay, so how this reaction goes, so I can write here, say solution. My solution is what? Say I am having my sodium and I am dissolving this sodium into ammonia. Okay, so this will form sodium ammonia complex Na NH3 time times X I am writing here. It will lose an electron, form a positive charge. Okay, and then it will form the ammoniated electron also E NH3, and I'll write Y here and put negative over there. So X and Y I have used here, so I can write X plus Y here. Basically X and Y, they are the stoichiometric coefficient, and it depends upon the concentration of the ammonia. When the your concentration is dilute, then the X and Y will have the different value. When your solution is concentrated, that means having the higher amount of the ammonia, then the X and the Y value would be different. But I am going to I am taking the generalized example in that case. Okay, and this ammoniated electron, this electron can transfer from lower level to higher level, and when it returns back, it gives some energy that falls in the visible region, which gives the blue color to the alkali solution. So this is the formation of the ammoniated electron. This is the correct answer in that case. Basically it forms the blue color. I can write blue here. However, there is no need to write the blue because I have already written the equation with the help of the blue. Okay, so if I check the options, so option D is looking correct. The free electron is trapped in the solvent cage. Basically ammonia is your solvent cage. Now moving to the next problem, what it says. Problem 14. Which reagent would enable you to remove sulfate ions from the solution containing sulfate and chloride? This is actually the simple test of the sulfate ion. When sulfate ion, you might have done this in your class 12 or class 11 and 12 during the analysis. Okay, so you are having a solution which is having the SO42 negative, and then you are having the Cl negative. Okay, and to this particular solution, what you do, you pass your barium hydroxide solution. You add barium hydroxide to it. So two compounds will form in that case. First is barium chloride, and second is the barium sulfate. Okay, and this barium sulfate is sparingly soluble. Sparingly soluble, that means its solubility is lower. When its solubility is lower, that means it will remain undissolved. That means it will form a precipitate. Okay, so this precipitate we can easily filter out. That means we can separate the sulfate ion from the solution. So your correct answer is the formation of the barium sulfate, right? Because it is insoluble, you can filter it. Now moving to the next problem. 15. When HCl gas is passed through the saturated solution of BaCl, it is not BaCl, guys. Let me correct it. It is BaCl2. Okay, it is typographical error from my side. Okay, so saturated solution of BaCl2, a white precipitate is obtained. This is due to the out of the four. You have been given 4 options. You have to select the first one. Barium chloride, your HCl, and your barium chloride precipitation. Okay, you have been given barium chloride 2 times. First is the impurities and second is the precipitation. So please remember, when you are discussing the solubility, there is no question of the impurities. Okay, because you are passing HCl gas and only then you are having the BaCl2 white precipitate, and precipitation actually will occur according to the concept of the solubility product. Okay, so in that case there is no question of impurity. So when there is no question of the impurity, you can easily strike out your 2 options A and B. Now you left with the option C and option D. Let's check how it actually is happen. It happens actually, right? Your barium chloride is there, BaCl2. Okay, and what is the condition for precipitation? When the value of the ionic product for any salt exceeds the value of the solubility product. That means when your ionic product has the greater magnitude, and this solubility product is having the lower magnitude, that means more ions are present in the solution, and when more ions are present in the solution, they actually remains the undissolved form. That means they will form the precipitate. So now let's check what is given here. You are passing the HCl solution through the saturated solution of BaCl2. That means in a container you are having already the saturated solution of BaCl2. Saturated solution. Okay, you are having the saturated solution, and from the outside you are giving the HCl. Okay, so what can happen in that case? Your BaCl2, if I write in the ionized form, it will give you the Ba2 positive plus 2 of Cl negative, and you are passing the HCl gas, that means H positive and Cl negative. So in that case you can see the Cl negative is the common here, that means this common. If it is forming a reversible reaction, if it is the reversible reaction, the concentration of the chloride ion has increased pretty much, so this equilibrium gets disturbed. So to according to the Le-Chatelier's principle, this has to be regained, that means equilibrium has to be regained. So your chloride ion should have been decreased from here, and they must lower their value in order to attain the equilibrium again. The only way to lower this concentration of chloride is what? It can again combine with the barium to form the barium chloride, because it is less soluble than the HCl. However, you can say that this chloride can react with the hydrogen to form the HCl, but this is the strong acid. It will again ionize to give these things. So the only way left is what? Chloride can react with the barium to form the barium chloride. So basically it is the precipitation of the barium chloride which is happening in the solution. So your correct answer is the option C. Okay, I hope you understood the problem pretty well. Now moving to the next problem. Complete the following reaction using following equations. Following options, sorry. A, B, C, D. Again, it's a theoretical question. There is nothing special about it. So if you have learned or memorized this reaction, only then you will be able to solve this one. However, this is the important method to form the oxides of the alkali metals. So if you have the potassium nitrate, which is given in the question, it is in the solid form, right? And you are having the potassium, excess of this metal. Okay. So it will react, it will form the oxide which is more stable than the nitrate, and your nitrogen will evolve from here. Please remember, potassium oxide is more stable than the nitrate, that's why this decomposition is happening here. Okay, so K2 plus N2 is the correct answer. So your option D in that case is looking correct one. Now moving to the next problem. Identify the products of the reaction Na, NH2 and carbon. Again, this is simple looking problem, and if you have memorized this, only then you will be able to solve this problem. So how I can write? I am having my sodamide actually, NaNH2. It is reacting with the carbon, right? So basically sodium cyanide will form in that case. NaCN will form in that case. Okay, and your hydrogen will be removed. Now moving to the next problem, that is problem number 18. Identify the products and complete the reaction. Okay, so how we can again, it is again a very simple problem where your sodamide is reacting with the laughing gas, because the reaction of the sodamide is important. That's why these you have encountered these the same kind of the problem twice. Okay, so I can write the formula here or the reaction here. So how we can write this particular reaction? Say you have been given your sodamide, which is your Na. You are having a sodamide, which is your NaNH2, and you are reacting it with your nitrous oxide, laughing gas. Nitrous oxide is what? Nitrous oxide is laughing gas. Please remember. Okay, it will form your sodium nitrite, NaNA3, and along with the removal of the water. So NaN3 and H2 is the correct answer. Option B is incorrect. It's a theoretical problem. Okay. Now moving to the next problem, what it says: in the following reaction, identify the products. Again, it's nitrate which is combining with the carbon. When nitrate is combining with the carbon, definitely you are going to form the carbonate. Okay, and nitrogen will remove from here. So I am doing here only this reaction, right? If you complete this reaction here only, so you'll get your potassium carbonate, which is your K2CO3. Okay, and nitrogen will be evolved from here and along with the carbon dioxide. Okay, so K2CO3, N2 and CO2. Option D in that case is looking the correct answer. If you want, then you can balance it also. Okay, I'm not going to balance this. Okay, and so it is already balanced, I think. One carbon. No, it is not balanced, but you can balance the reaction by your own. I'm not wasting time in this. Okay, now moving to the next problem, the problem number 20. Identify the products in the following reaction, KNO3 and KNH2. Again the same kind of the reaction. So if you have memorized this, so you can easily write potassium nitride like you have formed the sodium nitride somewhere. Okay, KN3 along with the alkali solution, that is 3KOH. I can write 3KOH and then NH3. Okay, so if you want to balance this, however there is no need to balance this. Okay, fine. If you put 3 here, then the reaction automatically gets balanced actually, right? So KN3, KOH and NH3. In option D again is looking the correct answer in that case. Now moving to the last problem of this section, and this problem you have studied in your class 10th, I think. Yeah, definitely in the class 10th. If not, then I can explain how the things actually happening here. What is the question? Which of the following elements called the bridge elements? And if you have memorized this question from right from your class 9th, you know your sodium and magnesium are the bridge. Sodium and magnesium are the bridge elements. So you can write option C as the correct answer. And if you want the solution, then I can give you the solution also. How? So I can shift this here. Now you can see here, this is my first A group. And in the first A group, I am starting with the lithium, and then I am going for the sodium, and then I am going for the potassium, and then rubidium, and so on, right? And cesium and francium. First A. Now if you see here, this is your first B. This group is what? First B group. Okay, see, you know, this is S block element, metals. These are the P block elements, metals, metalloids, non-metals. And in between the S and P, there is D block element, which is the transition element, which have the transition in the properties. These elements have the transition in the properties of the metals and the non-metals. That's why they have put it here actually. Okay, and this is first B. So what is there in the first B? After you see, after magnesium, here copper, silver and gold is there. So you can write it here, copper, silver and gold. So basically this sodium is forming bridge between this and this. In the similar way, if you take the second, right, so in the second you are having beryllium, you are having your magnesium, you are having your calcium, strontium, barium, etc. And this is your second A basically. Now you can check here your second B. This is your second B, okay, which is having zinc, cadmium and mercury, and it is just after your magnesium. So you can write here zinc, cadmium and mercury. So basically this magnesium is forming link between this and this, bridge between this and this and this. First A and first B, second A and second B. So that's how you can understand the problem actually. It's a quite simple problem. So I have done these 21 problems. I hope you understood the problem pretty well. If you didn't understand, not grasping that, if you are new here, right, if you are class 11th or the 12th students, or you are doing your graduation, okay, and you didn't get the much of the exposure of the inorganic chemistry, then what you can do, you can go for my lectures, chemistry of the alkali metals and chemistry of the alkaline earth metals, and then come back to this particular lecture. Then it will be very helpful for you. Okay, so in the next class I'll try to complete more 20 or 30 problems in the next lecture. So in the 4 and 5 lecture, I will try to complete the 100 such problems, and then I'll start your P block element. And so what I can do, I can start the P block element simultaneously also. Okay, so if you are watching video, if you are regular viewer here, please like तो कर दो यार, ठीक है? और if you are new student here, okay, and watching video for the first time, please subscribe the tetrahedron chemistry classes and do share with your friends also. Okay, I'll meet you in the next class with some other very interesting questions, either on the S block elements or the P block elements. Okay, that's it for today. Thank you very much.